Hello everyone, welcome to my channel Chemopath. Today we will discuss Wolff Kishner reaction. In this reaction, ketone and aldehyde reduces to alkanes. How? In the presence of hydrazine and a strong base. Like ketone in the presence of hydrazine and a strong base KOH. With small heat, it will convert it into alkane. Same with ketone. Hydrazine and KOH with small heat converted it into alkane. So how this ketone converted to alkane, let's discuss it with detailed mechanism. You will understand it better. So this ketone with hydrazine let make a lone pair here. These lone pair attack the carbon atom and the bond break towards the oxygen, then it attain a negative charge. So it is be like that. R1, let's see it's R1 and R2. R1, R2 attached to the carbon, this oxygen attaining negative charge, and this hydrogen nitrogen attached to carbon. Here hydrogen, hydrogen, and this nitrogen, NH2. What happened? This negative oxygen charge forced two hydrogen atom to lose their electron toward the nitrogen because it attained a positive charge here. So this grab this hydrogen, give its electron back to the nitrogen. What we get here now, R1, R2, this carbon atom get the alcohol group, this nitrogen attached to getting the lone pair back, this nitrogen and this hydrogen atom. Now this lone pair again form a bond with carbon and forced to leave the hydroxide group. Then what happened? This R1, R2 which attains to the carbon, double bond with nitrogen is formed here and H atom NH2. Here nitrogen attain a positive charge. Now it want to be get stabilized. That's why this hydrogen gave its electron back to the nitrogen, where OH negative from KOH is present. We have this, grab the hydrogen, form a water from it. We get R1, R2, this carbon, this doubly bonded nitrogen we have with this NH2. This structure is known as hydrazone. Hydrazone. Okay. Now this hydrazone formation is very important, for which lead to the alkane formation. Let's see how. Let's make a hydrazone here. Same structure. Beta, look at here. Look at here. Look at here. Same structure. R1, R2 attached to the carbon, doubly bonded nitrogen, single bonded NH2. Okay. We have it. Now, in the presence of KOH, what will happen? This hydrogen, this OH negative again forced to hydrogen to get their electron to nitrogen and it grab it. Then what happened? Then again R1, R2, carbon doubly bonded nitrogen, this nitrogen having a negative charge now, and this H atom. Okay, now this negative nitrogen became a part of a resonance here. This negative give electron to nitrogen, and this bond break down again. Now the carbon atom get a negative charge, right? Like इसको अच्छे सुंदर सा बना लेते हैं, अच्छा नहीं लगेगा ना ऐसे. ये C double bond getting negative charge, this nitrogen, sorry, single bond getting negative charge, this nitrogen with double bond NH. So this is the formation. In the presence of water, what happened? This is positive, this is negative. In the presence of water, this H positive ion try to attach a more negative ion where we have a carbon more negative as compared to the hydroxy group. So it attached to the carbon, negative carbon, and we have R1, R2, this carbon H atom bonded to nitrogen, double bonded nitrogen and hydrogen. Here we get this. Now we also have a negative OH ion here, which force hydrogen to give their electron to nitrogen again, and this grab it and force to break down this bond and form a nitrogen gas, which is more stable as compared to this structure. So we get R1, R2, C negative plus and triple bond N plus H2O. Yes, ultimately we have H2O now. Now this structure. This structure cannot be stable in the presence of H positive ion or water. We get R1, R2 attached to carbon, hydrogen and hydrogen. Here we get alkane from aldehyde. So I hope it's look like easy to you, and by practices you will understand it better. And thank you for watching.